Good afternoon, everyone. Thank you for joining us and welcome to this talk on hearing the past. I'm going to start with some introductions from who you're going to hear from, and then we'll get straight into the meat of the discussion. First of all, I'm Rupert Brunn. I'm an audio innovator. I work as a consultant for technology companies and broadcasters in the media sector, and I'm also a committee member of the IET Media Network, who do things like organising these events. Our speakers today are Mariana López. She is a professor of sound production and post-production at the University of York. She specialises in two main fields. Firstly, the study of acoustical heritage and historical soundscapes, and secondly, in the use of sound design to create accessible experiences for visually impaired film and television audiences. In her talk, she's going to start by introducing attendees to the methods used for acoustical heritage research. Her book on this subject, Sonic Pasts, Acoustical Heritage and Historical Soundscapes, is now available. Then we will hear from Amy Woods, who graduated from Solent University in 2024 and began working within the broadcast industry as an audio engineer. She will present a central case study based on her dissertation, The Acoustic Analysis of the JFK Assassination. I'm sure you will have lots of questions for them. We will be taking questions at the end after we've heard from both of the speakers. So please make sure you put your questions in the Q&A box, which you should see on your screen. If you put them in the chat, we'll try and corral them and put them together, but it makes it easier for us if you put them in the Q&A box. Thank you. So without further ado, I think I am ready to hand over to Mariana for her to give the first talk of this presentation. Thank you.
Thank you very much. I'll just share my slides, everyone. Just give me a moment to make sure everything is working fine. To make sure we can hear the sound afterwards. Cool. So I'm just going to put that in presentation mode. So hopefully you can all see that on screen and hear me, but do someone let me know if that's not the case. So thank you so much for having me for today's presentation. I'm going to dive right in. I'm also going to put it on a timer just in case I get too enthusiastic about the topic. So the first thing I want to do is to really unpack the concepts of acoustical heritage and historical soundscapes for you all, in case this is something that is new to you. So what does acoustical heritage mean? It means really the study of the past and past environments through the consideration of the acoustics of those environments. By environments, really, it could be loads of different places. So it could be outdoor spaces, it could be indoor spaces, it could be built environment, it could be natural environments, whatever it is that might have some sort of significance in the heritage sector. And that sort of significance can be very wide, of course. But also we have the study of historical soundscapes, which is slightly different. And by soundscapes, when we think about them in the context of history, we're going to be talking about the combination of sounds that people might have experienced in a particular area at a particular time. And those soundscapes would have as now been fluid. So the soundscape I'm experiencing now while I'm in this room is going to be different from the one that I'd experience if I went to another room of this building. But also soundscapes change from day to night, depending on the time of the year. So a summer soundscape is different to a winter soundscape, etc. So those are all things that we need to consider when we do this work. But really importantly today, we're going to be talking about loads of technical aspects related to the study of the sounds of the past, but we need to remember that we do not hear in the same way than people in the past heard. So if you went and read loads of literature from a psychology perspective, you would generally kind of read about the hearing mechanism or other senses as things that haven't really changed much. But actually, culturally speaking, how we perceive sounds and other sensorial experiences actually has changed quite a lot. So we don't hear in the same way that people in the past heard, and the way in which sounds are granted meaning is not the same. But also this changes across historical periods in different regions. So something to think about when we do this work, and we'll come back to this later on. So approaches, how do we study the sounds of the past? Impulse response measurements, if we start thinking about acoustical heritage, the main way in which we study the sounds, the acoustics of the past, is through impulse response measurements. And in very clear, kind of a concise way, it is the study of how a space reacts to a sound emitted in that space. And by studying spaces through impulse response measurements, it can tell us, for example, how intelligible speech is in a space, how clear or blurred musical notes are within that space, and even how broad a sound source might feel or how enveloped a listener might be. So those are all things we can do through impulse response measurements. And how do we actually do them? So we're here on the screen, we have a photo of King's College Chapel in Cambridge from quite a few years ago. But it's a setup for impulse response measurements, so we'll use it didactically. So we have a loudspeaker there in the pulpit area. Loudspeakers are the most commonly used type of sources for this type of measurements, although not the only ones. Generally what we use is sine sweeps, so sound signals that sweep from very low frequencies to really high frequencies, generally coinciding with the human range of hearing. Those, as we will see, are kind of played back through a laptop or other device. So that's our sound source. Then we generally use a combination of microphones. So the most common type of microphone that is used for these measurements are ambisonic mics. So that's a sound film mic there in the choir area. So that is what is called a B format microphone with 4 channels that capture sound all around it. Then we have our very amusing dummy head, which is a dummy head with ears inside it. Sorry, not with ears, with microphones in it. Its ears. That makes much more sense. So it has microphones in each ear. And the idea with those measurements is that you're considering how the head, the ears, and not in this case, because it doesn't have a torso, but if the dummy head has a torso, it also includes the effects of the torso on how we hear sound. And there we have, in this case, myself looking probably quite stressed, but thankfully quite blurry as well. And I have everything connected to a laptop and a sound interface. So what we're doing is playing the sine sweep at the same time that we re-record it back. So we're recording the response of the space to that signal. And what we have is that we work with a combination of source receivers. So when we're working in large spaces, more specifically, it is unlikely that we will do one impulse response measurement. So we wouldn't have one source, so one loudspeaker position and one microphone position. We generally change them and do a lot of measurements to try to determine whether there's changes to sound depending on the position of, say, a speaker and a listener. So what do we do after we do these recordings? We do a process called deconvolution. So we separate the original signal from the response of the space to that signal. And really what you end up is with a not very exciting sound that sounds a bit like a hand clap, but it isn't a hand clap. And that is the impulse response. And it is that impulse response that you can use to understand, again, speech intelligibility, musical clarity, envelopment, etc. So this is a very, very quick explanation of how we do acoustic measurements. And here there are a few more photos for you to see different setups. So this is a setup in Bristol Cathedral, so slightly different type of loudspeaker, but again, the ambisonics mic is there. This is another one, and I wanted to show this one because what we have on screen is a dodecahedron loudspeaker, which is much. It's not something you would encounter every day. We don't even have one at the university. We tend to hire one if we need one. But if you're interested in doing measurements that follow ISO standards, generally this is what you would need to use. Cool. So what we've been talking about so far is when we want to study a site from the past, and that site exists and we can go and measure it. And it exists in a way that it is the conservation is enough, the state of conservation is enough so that you can go and measure it. But there are many circumstances in which we might be interested in studying a space that either no longer exists or it doesn't exist in a full enough way to make sense to measure it. Think about abbey ruins, how many times you might have encountered an abbey ruin in England where there's just one wall. And doing acoustic measurements with just one wall is not going to give you any meaningful results about the past. So those are circumstances in which what we do is use virtual models. So these are specialized acoustic models. So I'm using here the images from acoustic models from my colleague, Dr. Lidia Alvarez Morales, that led the Cathedral Acoustics project here in York. And some of the images before from caves are from the project Acoustic Atlas by Dr. Covey van Tonder, and both projects were funded by the European Commission. So what we have here, we had before a photo of the Lady Chapel in Ely Cathedral, and what we here have are computer models of that space. So on the right-hand side, we have that space modeled as it was in 2019. And why 2019? It's 2019 because that was when we did the acoustic measurements of the space. So what is happening here? So we went and measured the space, as I explained before, and Lydia was interested in seeing how the acoustics of the space had changed throughout history. So we need to move to the realm of computer models. But before we can model the space as it was in the 14th century, what we need to do is to make sure that the computer model is accurate. And this can be quite tricky to get acoustic models to really reflect reality. So what we generally do is we do acoustic measurements, then we build the computer model exactly as the space was when we did the measurements. And when I say exactly, it means that if there's scaffolding on one wall, we need to model the scaffolding as well, which has happened in the past. Once we have the computer model, what we do is we calibrate it. So we run tests to see how close the results of the computer model are to the acoustic measurements on site. And then we make changes to the computer model until it is as close to reality as possible. I'm not going to go into the details of how we do that because it's quite a slow process and I don't have time, but I'm happy to go into it later. So once that is calibrated, so we know our tools of study are working properly, we start changing the space to reflect what we know historically that space was like. So in the middle image, you have the space in the 1930s, and then you have a 14th century representation. And this is based on changes that are reported in historical documents and archives. From these computer models, we actually do something similar that what we do in on-site measurements. So we place sources and receivers, and for each source and receiver, we generate an impulse response. And that impulse response, again, can be used to understand how the space responds to sound a little bit better. But thankfully, what we can do when we study the sounds of the past isn't just look at numbers and acoustic parameters. The world would be quite boring if we just did that. So what we can do is also hear the past. So we can hear what the spaces might have sounded like in the past. And I say might have sounded like because there's loads of unknowns, including the fact, as we said before, that we don't hear the same than past people, and we don't assign the same value to the same sounds. But what we can do is a process that is called oralization, that is based on convolution reverb, that is represented there through my friendly capybara friend. So on the left-hand side, you see our friendly capybara that is doing its thing. That represents a recording that is generally done in an anechoic chamber, so a space with no acoustic reflections. Then in the middle, we have the representation of a space that would be our impulse response file. And what we do is we do a process of convolution by which the sound of that recording would be we would apply the sound of the space, the acoustics of the space to that recording. And that is what allows us to do oralization. So we will hear that sound as if it had been recorded in that space, but it was never recorded there. And we can do that with acoustic measurements, and we can do that with virtual models. And we can also do walk through the spaces to hear how the acoustics change as a person or a capybara moves through that space. So what I'll do is I'll play a little extract of a Gregorian chant piece that was recorded by Pierre-Philippe Deschamps as part of Lydia's project, and you will hear the anechoic start, and then you will hear how it was oralized. So hopefully you will be able to hear that.
Gloria in excelsis Deo, et in terra pax hominibus, bone voluntatis, loduamus benedictimus Te, adoramus Te, glorificamus Te, gratias audimus tibi.
And hopefully you could hear as well that lovely tail at the end of the recording. And maybe you even, did a sing along there, who knows. So that is kind of a summary of how we study acoustical aspects, but I'd like to draw my attention a little bit to the aspect of historical soundscapes, because the way we study soundscapes is quite different to the one in which we study acoustics. So with historical soundscapes, a lot of the work will involve looking at historical sources. It could be documents written in the past, archives, etc., to see whether there's been mentions of sounds and what value is assigned to that sound and what people are literally writing about them. We also use archaeological remains. So, for example, if there's remains of animals in a certain area from a certain period, we know that those animals were present, and we can safely assume at that time in the past, they still made sounds like they did today. So we know that we can use that work to look into soundscapes. The only caveat with this sort of work when you're working with documents is that we always need to think about who wrote something and why they were writing it. Sometimes we find cases of people that were writing about certain sounds because they wanted to make themselves look more important for others reading their work at the time. Or we can also find instances of racism, whether how certain sounds are associated with certain people is linked to racism. And that is definitely in those documents. So we need to be a little bit cautious as to what conclusions we draw. But to give you an example, we have some images there of recordings I did for a project called the Soundscapes of the York Mystery Place. This was quite a long time ago, but we have a pig, we have dogs, we have sheep, and that is because there is evidence that at the time in which this medieval drama cycle happened in York, that was from the 14th to the 16th century, these animals were in the region. So we went and recorded animals that we knew would have existed. And of course, they're not medieval pigs, they're not medieval sheep. I can only work with the pigs and the sheep I have, but it is absolutely acceptable to do that. And we use quite traditional sound recording techniques to do that. So those are shotgun microphones on the photos. And also there's an image of a bell, again, medieval England, very, very big on the bells, a lot of significance to them. So that is actually a medieval bell that is kept in York. So a very different way of studying sounds in this area. But what I wanted to do is to explain this a little bit further, is tell you a little bit about this project and then play you a little demo video so that it's a little bit clearer. So we said that the York Mystery Plays were a series of plays that were performed in medieval York. That's the north of England from the 14th to the 16th century. They were performed outdoors. And we don't know that much about how they were performed, but we do know they were very important in the period. So what you see there on screen is an interface that we built to study, to allow people actually to play with the acoustics and the soundscapes of the past. So everything was based in rigorous research and computer models on the period and the performances, but also the idea was that people could navigate different possible past scenarios. So what would happen with acoustics if it was performed in this way, or this other way, or this other way? And what would happen if we consider different sounds that might have been present at the time? So the performance audio triggers an anechoic recording of extracts from the plays. And then if you select one of the ovals towards the top of the screen, you can change the performance setting, which changes the acoustics. So it triggers an auralization. And then on the wheel, you can trigger different sounds, change the levels to simulate distance and others. And you can also hear oral commentaries from people that currently keep the tradition of the plays alive. So what I'll do is I'll play a 1-minute video or so that goes through the interface so that you get a feel for what it sounds like. This sort of things is generally better experienced over headphones, but if you don't have headphones, that's also fine.
and see. He is not here, be soft or sigh. The place is void, that he in the lion. Be sorcery here, see him I, was on him alive.
So that was Middle English, if you were wondering. Cool. So what I'd like to do is, in the last few minutes, just now that we've covered kind of the general kind of definitions and approaches to studying the sounds of the past, a little bit about the importance of interdisciplinarity and how ethics comes into play. So I have already been hinting quite heavily that it's not just about technical methods. It's not just about acoustic measurements or sound engineering. It's much more than that. It's about thinking about the sound from a historical perspective, so the field of sensory history, but also look into anthropological approaches to sound. So it's much more complex than just us doing the measurements. But also, it's always considering what I tend to refer to as humanities and social sciences approaches bring to our understanding of those measurements that we do, while also reflecting on the possibilities that technological advancements bring to our understanding of the past. But what I think is really important, and what the humanities and social sciences brings to acoustic engineering and other studies, is really an opportunity to reflect a bit more widely as to the biases of the field. So I have spent quite a lot of time in the last 2 years looking into the field as a field of study and what are its opportunities, but also the challenges and shortcomings of the fields. And one of them has to do with a very obvious Eurocentrism. And what I mean is here, what spaces are chosen? So what do people study and why? And we had good examples today. We had a set of European cathedrals and a piece of European drama as well. And this is replicated a lot in studies on acoustical heritage, particularly. But also within European context, we can see a privileging of certain historical periods over others. So, for example, more recent periods get studied less than further away periods. But also, when I studied medieval drama from an acoustical perspective, something that I found was that if you bought a theatre acoustics in theatres throughout history book and some very, very well-regarded volumes, they tended to jump from Greek and Roman theatres to Elizabethan. And I'm like, oh, there's quite a lot of years in between those two things. And a lot of it has to do with kind of this neglect of medieval drama, I think, and its acoustics, I think has to do with the fact that this type of performance didn't leave behind material remains. So there's no wonderful looking theatres to explore. There's not even archaeological remains except the streets of York. But also there's a lot of preconceptions about what the medieval period produced. And you might be familiar with people saying, oh, that's like in the Dark Ages. And of course that's nonsense, but that has permeated how the field and many other fields look at certain periods. But also this connects back, the problem of Eurocentrism connects us back to issues of Orientalism that we see in the field. And here I'm borrowing heavily from Edward Said's work and how certain types of heritage get valued more than others. And one example that I always give is if you look back recently, if you think back to a recent event, 2019, Notre Dame goes on fire. A lot of worry about the site online in journalism. But sites in the Middle East also get heavily affected by loads of different problems and contexts, and we don't hear about those heritage sites. So we need to ask ourselves why we're not hearing about it. But also, this is not the end of the biases of the field. We generally think, see gender biases in how, especially in earlier studies in the field of acoustical heritage, in which certain conclusions, let's try to put this delicately, certain conclusions about what the acoustics of a space reveal about its use are very, very heavily influenced by the what someone already thought about gender roles in a certain historical periods. But also we see an underrepresentation, for example, about from disabled experiences in the past. And also, I personally believe that the field has mostly focused on positive heritage, so things we like thinking about, but not that much focusing on the acoustics of heritage sites that are places of trauma. So thinking about concentration camps, detention centers, prisons. But this is still a part of sound heritage, and many of the sites are heritage sites themselves. So here what I'm trying to say is that technical work needs to be accompanied by a broader understanding of what the field is doing and why decisions are being taken. And there's a really great opportunity for working in an interdisciplinary way to see how we share the sounds of the past and how we provide transparent renditions of those sounds from the past, and thinking about, embracing those unknowns, the things we don't know about the sounds of the past, but also becoming more comfortable with the familiarity of acoustic and sound experiences. So thank you so much for listening. If you're interested in learning more about this, as Rupert said, my book Sonic Pasts, Acoustical Heritage and Historical Soundscapes is now out. So I'm going to finish now and pass on to Amy. Thank you very much.
So today I'll be presenting you with a case study, which I researched and created a 3D modelling project for my final year dissertation at university. This idea was suggested by my lecturer, Lee Davison, which really intrigued me. There was a short YouTube video on the confusion of the event, which sparked the idea on how this can be investigated from an acoustic side, as well as a possible virtual model. I'll talk you through some of the background of the event with some theory on gunshots and binaural hearing, and then present you with the project and results from my dissertation. So these are some statements from witnesses after the assassination took place. It was hard to tell because they had an echo, There was actually 2 explosions with each one. There was the shot and then the echo from it, so it was hard to tell. Right there around that concrete little deal on that knoll, sounded like it was in that area, between the underpass and the building right on that knoll. There was no question in my mind as coming from the direction of the building known as the school book depository. You can see there is disparity between these 3 statements and why there was so much controversy about the assassination. The confusion in these statements may start to make more sense once we explore the acoustic theories and look at the test results later in the presentation. So here's a little backstory of the event. John F. Kennedy, the former president of the United States, was assassinated on November 22nd, 1963. This occurred while his motorcade traveled through Dealey Plaza, Dallas, Texas. Lyndon B. Johnson tasked a commission led by Chief Justice Earl Warren to investigate John F. Kennedy's assassination. The Warren Commission concluded that Lee Harvey Oswald acted alone, firing 3 shots from a Mannlicher Carcano rifle, with 2 hitting the target. These were shot from the 6th floor window of the Texas School Book Depository, shown by the red arrow in the image. Following the release of the Warren Commission report, many people who were at the event disagreed with the information published. Here is a diagram of Dealey Plaza, which I have overlaid with estimated positions of bystanders. Where a report has been taken, it has been marked with a dot. The colour represents the direction or where they had perceived this shot. The number shows the quantity if mentioned by the witness. From this diagram, you can see that there are many different perceptions. You can also see where there are multiple statements taken in one area, there is no definitive location to where a group has collectively agreed. So, for example, at the Texas School Book Depository, it was mixed in perception. The green dots show that those witnesses had heard gunshots around and toward the vicinity of the grassy knoll, whereas the witnesses in blue had heard the shots to be located around them or behind them coming from the Texas School Book Depository. Others in purple heard them from over by the underpass, and the rest in orange were not asked or it was unknown. There were 2 main points I wanted to have a look into, which was why was there such an inconsistency regarding the location of the shots, and why was there varying accounts of the quantity of shots heard by the witnesses? Before I talk about my analysis into these questions, I'd like to talk a little about the phenomenon with gunshot acoustics. So when a firearm is discharged, it produces multiple sounds, the shockwave from the supersonic bullet and the muzzle blast from the high pressure gases escaping as the bullet leaves the barrel. Additionally, reflections and echoes from surrounding surfaces create another acoustic stimuli. When a bullet travels at supersonic speeds, it creates a shockwave in a cone shape with the bullet at the tip. The muzzle blast spreads in all directions at the speed of sound, with the most energy aligned with the gun barrel's aim. This diagram shows that the perceived trajectory of a shot changes during the rifle's discharge. Initially, at time 1, the shockwave reaches the observer before the muzzle blast, making the sound appear to come from the bullet's path. Later, at time 2, the blast wave arrives, making the sound seem to come from the muzzle's direction. This effect is known as front-back reversal. As the observer moves further from the muzzle and closer to the bullet's path, sound localization is more likely based on the shockwave, leading to incorrect perceptions. Binaural hearing significantly affects the perception of a shot's location. Sound localization relies on binaural cues or interaural differences, which are differences in timing and intensity of sound reaching each ear. In a scenario where a sound source is positioned 90 degrees to the right of an individual, this will result in a high intensity being perceived in the right ear compared to the ear on the opposite side. When the sound source is positioned at 0 degrees on the azimuth plane, there is little difference in timing and intensity between the ears, which can lead to confusion on whether the source was behind or in front of the listener. So from all of this, you're probably wondering what I did next. Obviously, I couldn't fly to Dealey Plaza and replicate this or sit and do 1,000 equations, so I did the next best thing. I recreated it in Unreal Engine. I'll now play a video where I'll be talking through and showcasing the method to build in the space as well as demonstrating the data collection.
This is the world I created in Unreal Engine, which allows you to walk around in first person when playing as a game. The map partly integrated a pre-made SketchUp scene which was scaled and aligned with Dealey Plaza building dimensions. The grassy areas, roads, trees and remaining buildings were built using shapes and each material was set. The original SketchUp scene was geolocated and had relevant topology. A wave-based audio engine called Project Acoustics was used, which can interact with 3D modelled spaces. It considers effects such as occlusion, which is the obstruction of sound by objects and obstacles, portaling, the passing of sound through openings, and reverberation, the reflection and echoes caused by sound bouncing off obstacles. Baking acoustics allowed for the audio to understand which geometry in the 3D world would impact the acoustic simulation. This was done by simply clicking and tagging objects which would have reflective properties, seen by the blue cubes. Navigation tags defined where the player could navigate within the acoustic world and informs where the listener probes are placed for wave physics simulation. Once all objects and locations were tagged, the absorption coefficient and material for each surface were entered, as seen in the last column. The absorption coefficient is a metric to measure how much sound is absorbed and not reflected. An audio stimulus was positioned in the 6th floor window of the Texas School Book Depository, which used Project Acoustic attenuation settings. When testing, listeners wore circumaural headphones and were prompted to articulate their perception of the shot's location and if multiple shots were perceived. The listeners who were subjected to the test were handed paper with multiple polar grids with radiuses of 15 degrees. They were instructed to draw a cross where they had heard the shot to be. After, this was aligned to the direction faced within Unreal Engine at each testing spot and plotted on a photo of Dealey Plaza for easy visualization. The listeners were not aware of the background of the testing. It is important to note that only one audio stimuli was present of a gunshot. To save confusion and to dictate if a second shot was heard, it would be presented as an echo. The shot was positioned at the Texas School Book Depository to simulate the conclusion from the Warren Commission. If the statements of those based both in the unreal world and the original event had agreed a shot came from the same location, which was not its original source, and were both stood in the same spot, it would appear it is most likely based off reflection and came from the Texas School Book Depository.
So I just wanted to highlight some things mentioned throughout the video. The Warren Commission concluded that the shot came from the Texas School Book Depository. I recreated Dealey Plaza in Unreal Engine using that assumption, aiming to test whether people's perception of the shot's origin could reveal how acoustics may have influenced witnesses. For instance, if witnesses at the time believed the shot came from the grassy knoll and participants in the simulation also pointed to the knoll, despite the sound being placed at the depository, it would suggest acoustics played a role in shaping that perception. If similar patterns appear across multiple locations, it will support the idea that the Warren Commission's conclusion about the shot's origin was likely correct. So on to the results. I'm now going to compare what the listeners heard in Unreal Engine to the Warren Commission witness statements. At the Texas School Book Depository, listeners often misidentified the direction of gunshots. Testing showed that some perceived the shots as coming from in front, others from behind or to the left and right. Standing in the trajectory caused the sound to reach both ears simultaneously, and the intense sound pressure level contributed to directional confusion. The listeners in light and dark blue could not decide whether the shot was behind or in front of them. In relation to the witnesses' accounts collected after the assassination, witnesses near the Texas School Book Depository reported perceptions similar to the experimental findings. Where the witnesses believed the shot to be by the grassy knoll or underpass, this could align with the findings where listeners may misidentify the location due to the sound reaching both ears simultaneously, leading the shot to be being perceived in front. A group of people, both in the experimental findings and real event, both agreed the shot came from the Texas School Book Depository, as well as from in front, possibly leading to identifying the shot from the grassy knoll. The binaural effect likely played a huge role in this area. Listeners at the north reflecting pool mostly perceived the gunshot as coming from the right or slightly in front, though some heard it slightly behind to the left or right. Localization was largely accurate, aligning with the shot's origin at the Texas School Book Depository. This accuracy likely resulted from the sound source being 90 degrees to the right, maximizing intensity differences between ears, and the relatively short distance reducing interference and enhancing auditory clarity. Reflections from nearby buildings may have influenced some perceptions, but did not alter the conclusion that the shot came from the northeast side of Dealey Plaza. The results from the north reflecting pool were also nearly identical to those stood in the plaza when the assassination took place. Due to the shorter distance from the shot's location and the angle the listener was stood at, both group of listeners could have been more likely to locate the shot. Listeners on the grassy knoll mostly heard the gunshot from the left, around 30 degrees plus or minus toward the Texas School Book Depository, though some also heard a faint shot from the right, near the underpass. This may have led bystanders to believe in multiple shots, though reflections likely caused the effect. Reflections off buildings and the pergola, with its concave structure focusing sound to a central point, created loud hotspots and delayed echoes. These effects could explain the confusion about the gunshot's location and the perception of an additional shot. The grassy knoll location had the least relation between witness reports and the experimental findings. From the statements made by witnesses, the majority believed the shot to be located from the grassy knoll. Dependent on distance, this could link to the experiment. However, it's hard to pinpoint where on the grassy knoll it was perceived due to its large area. More people in the experiment had heard the shot to be toward the Texas School Book Depository. There are multiple factors which could have explained this area, such as the lower sound pressure level in the game, as well as no potential of recreating a shockwave, which could have affected where witnesses had heard the shot if the shockwave hit the listener at the grassy knoll. So I've only done 3 out of the 6 reports as they were the most significant, and from these findings, I can conclude that the inconsistency with the location and quantity of shots was heavily influenced by the location the witnesses were stood at. Those standing directly in the path of the shots experienced confusion due to the simultaneous intensity and timing of the sound in each ear. Witnesses located farther from the source were subject to additional environmental acoustic effects, such as interference from buildings and sound reflections. Furthermore, the direction the witnesses were facing impacted their ability to localize the sound, as changes along the azimuth plane altered the binaural effects of intensity and timing. Agreement between tests and witnesses suggests some localizations were influenced by reflections, with the shot likely originating from the Texas School Book Depository. However, the grassy knoll showed inconsistent results, with the most shots unlinked to witnesses' accounts. So using virtual worlds for audio analysis. So using Unreal Engine to recreate the plaza helped me visualize the setting and the points in the world I wanted to test, and allowed me to recreate and simulate an audio space which would have realistic acoustic effects using Project Acoustics. I also was able to create the world for free using some existing 3D models and photos, so this would not be an expensive thing to do. There were some limitations of Unreal Engine, such as not being able to recreate the shockwave. However, for any other scenario where a source or sources don't travel faster than speed of sound, Unreal Engine would be a great way of showcasing that. It was also my first time ever using anything like Unreal Engine, so I probably didn't use all the available tools, which could benefit other virtual scenarios. However, I used all I needed for my dissertation. Moving forward, I would retest again with a shot from the grassy knoll to see how perception changes and whether there is correlation between the original statements. I used the Texas School Book Depository to distinguish if witness statements would align to the Warren Commission, which many people disagreed on. As I've recreated the whole plaza as an acoustic space, it would be interesting to see other areas as well. For my dissertation, I chose the areas with the most disparity to test in Unreal. However, there were some interesting statements from people stood around corners of buildings, which may be good to investigate. So I just want to say thank you for listening, and a huge thank you to Lee Davison, my university lecturer who supervised this project. He helped me so much throughout, and I'm so pleased and proud to be able to present this project to everyone today. Thank you.
Right, thanks for that, both Mariana and Amy. They were both really interesting talks there. I think we're ready to jump into the Q&A now. Rupert, are you there?
Yes, sorry, with astonishing predictability, my internet chose the sort of last minute or two of Amy's presentation to completely go down, even though I'm on a wired connection and it's normally reliable. But hey, there we go.
Perfect timing, like you say.
Perfect timing.
To the Q&A. So I think we've had a few questions come in, but I will leave it to you.
Thank you very much indeed. So here we are. Right. So we have a question from Danny for Mariana. Do people also do research on historical industrial acoustics and soundscapes, because these change and disappear very rapidly?
Yeah, thank you so much, Danny, for the question. Yeah, there's some research. I might be wrong about this, but I've encountered more of that type of research in soundscapes work than in acoustics work, partly because of what I was hinting at before, that there has been biases in the field as to what spaces people have gravitated towards and what they feel is of interest to study. I have definitely seen creative work that used the acoustics and soundscapes of industrial spaces to create maybe an electroacoustic composition. But you're absolutely right. Industrial soundscapes change, and they kind of the idea of kind of capture and rethinking and maybe even conservation is really, really important as we experience those changes. So thank you so much.
Yeah, I can imagine that the soundscapes of the Industrial Revolution era might have been quite fascinating. Question from Liz. So you mentioned, Mariana, that people in the past heard things differently. And I can imagine that perhaps in the past there were a lot less loud noises than there are now, far fewer of those. But how do we know that people heard things differently in the past?
Yeah, really, really good question. This comes up quite a lot. So a lot of the work on this field comes from sensory anthropology, and the work anthropologists have done throughout many decades, looking at how sensorial experiences change from one culture to the other. So we might have records of people not kind of certain cultures not even have, let's say, certain names, words for certain colors, for example. So that has quite a lot of an impact, but also the value assigned to certain sounds, or even just going back to what Rupert was saying, what is noise and what isn't noise is a cultural definition. So what one person might think, oh, that actually is a terrible noise, I don't like it, for the other one is a pleasure. And even think about, someone going to a heavy metal concert might think, oh yes, that's wonderful. But if my colleague here next door was playing heavy metal, I would think, oh, actually, I'm not really enjoying that sound. So even within kind of the same geographical area and even within the same culture, we might also see different constructions. And there's differences in relation to gender as well, in terms of also socioeconomic. So what experiences do people have of their sonic worlds change depend on who you are. So it's really, really interesting for us to have those thoughts in mind together with any other data we might want to use. So I hope that answers the question.
Thank you very much indeed. So we've got one more question, which is for Amy. But before I go on to that, I will just say to people, please, we have got time for a couple of more questions if you'd like to type them into the Q&A box. But if we don't get any more, this will be the last one, and it is for Amy. And it's Danny again, who wants to know, How did the use of headphones in your trials affect the conclusion that you reached, compared with how it would have sounded to listeners who were actually at the scene hearing things in free space?
Yeah, so the use of headphones in my scenario worked pretty well to like replicate a binaural field. I didn't have like headphones were easy so that I didn't need to like set up loads of speakers and then be able to use that. But I'd say the downfall is people who heard it at the time would have heard it way louder than I was allowed to play it to people. So then the initial shock from people hearing it at this time would be very different to like people hearing it then expecting another shot after that and then expecting another shot. So it sort of changes that like dramatic trauma, like I can't remember the event sort of scenario, which happened to a lot of people at the assassination. But yeah, so I think it worked well in a sense to like replicate but a binaural sound, but then it limited me in I think I wouldn't be able to do that anyway with speakers. So that was probably just an overall limitation, really. But yeah, hopefully that helps.
Well, helps me, thank you. Yes, I understood. That's good. So thank you very much to our speakers for a fascinating discussion. I both presenting very different aspects of the topic from very different points of view, and I've thoroughly enjoyed having the talks, even though this is overlapping very much with my own area of interest. I've still learnt an awful lot this afternoon, much food for thought. Before we leave you, I would just like to tell you about a couple of other things that are coming up. So, oops, I should have done Shift F5, not F5. There we go. So this presentation has been brought to you by the Media Technology Network of the IET. There are other technical networks as well, and they are different. It's great for building up your CPD record. Lots of the events are low cost or no cost, as this one was free and online. We do also have in-person events. You can find a lot of specialist content, and it's great for multidisciplinary learning because it doesn't cost anything and lots of them are online. You can just drop into things that are not perhaps your main area of study, but which you think just might be interesting. So you can find out more at the IET website for the technical networks. We also have large amounts of content available on YouTube. So if you go to YouTube and search for IET Media, you'll find a very large number of videos where we've recorded talks on a vast number of media related subjects. And you can consume those at your own leisure. And if you keep an eye on our LinkedIn profile, you'll be informed about events that are coming up, and it gives you an opportunity to join a bit of a discussion about that. Future events, well, obviously the big media event of the year is certainly in Europe is IBC in Amsterdam, which is 12th to 15th of September 2025, and we will be presenting talks there. We will be present, so you can come and meet us there. We will have a What Caught My Eye presentation in September. And finally, for those of you interested in the audio aspects of the media industry, we have the Radio Technology Conference, Radio TechCon, which is a one-day event held in person at the IET in London. And it focuses on technology that is relevant to radio, but they don't just cover radio. They cover any aspect of technology that they think might be interesting to people who work in radio. So, for example, one year they had a talk from a woman who was the head of sound from space at NASA. And if you are a student and can't normally afford to travel to in-person events at swanky venues in London, then bursaries are available to help with the cost of tickets for that and to help even with travel costs. So if you go to the Radio TechCon site, you will be able to find out more about that. So that's it. Thank you very much indeed. I think unless any of my panelists or Gemma have anything further to add, I think we're done. No, we're done. So it just remains for me to thank Mariana and Amy for the work they've put into giving us such fascinating presentations. Unfortunately, on Zoom conferences, you can't really give a good round of applause. It doesn't work. But I'm sure there's a virtual one. There are certainly many complimentary and kind comments in the chat box, which I'm sure we'll look at later, saying how much people have enjoyed this. So thank you to our audience for turning up and listening and asking such good questions. And we'll bring it to a halt there. Thank you.